Yes, thank you, Amanda. It's good to be back at CakeFest. Thank you for having me. So I'm going to share my screen. There we go. The topic of today, refactoring with the factory design pattern. On today's agenda is a little bit about me, the introduction on how I came about this topic, the factory design pattern, my take on it, to detect patterns in some legacy code that I've prepared. And
Sorry,
to
Paul, we're not seeing your screen.
You're not seeing my screen.
No.
Oh, rats. Oh, there. Did it
Sorry.
fix?
Yes.
Good. Oh yeah, and all the source code that I'm talking about is online on GitHub. This is the URL. I will share it at Slack as well. There you go. So yeah, the topics after the patterns that can you see the presentation?
Yes.
Oh, okay, cool. So after the patterns that we've seen in the legacy code that I've prepared, we are going to apply the factory design pattern. And after that, we're going to have a proof of the pudding and use some unit tests to see if they actually work. So this is still me. I've been developing in CakePHP since I've been working here at Center Data. Really enjoyed this, so I hope to keep doing this for a long time. I like doing camping trips. We have an old caravan, I construct them. I sing and I play the big double bass in a band called Moonshine Brigade. Go check us out on Facebook, Instagram, YouTube. So what took me to this topic? Well, we have a long time project called Iptone, and we have the Ministry of Education that's asking us to measure if the teachers that are before a class are qualified to teach on that topic. Sometimes schools are short on staff and they will ask a teacher to give a class on another topic. They might be qualified or they might not. So we ask each school each year to provide us with a file of their scheduling software, and we will run it through our software and we will determine whether the teachers were qualified to give those lessons. So we started off in 2013, and last year I had the opportunity to overhaul Cake 2 to Cake 4, which was very nice. I saw beautiful switch statements that were really blossoming like trees. And well, what do you know? I mean, it's 2013. So yeah, that happens. So we have the design pattern, factory pattern as a solution partly for that. So what is it? Well, a factory design pattern is like make me object. You might be in a situation that it's dynamic and you're not really sure beforehand what you're dealing with, but you know that there are certain things in common. And the things that are in common you can put in an interface so you know which methods will be present at the given object. A very popular design pattern of a factory design pattern is Faker. A lot of you guys probably know about them. You can just say, hey Faker, give me some fake data in English, and it will give you an object. I can say, hey, make it in Dutch. It will give me an object. And the same methods will be present in both objects. And underneath the hood, there will be an English class with properties in English, but I'm not concerned about it because I just get a class and I call upon the methods that I know that are there. So that's my take on a factory design pattern. You can just get a class and you can be certain that some methods are in it. There's a nice blog article, it's not very recent, it's pretty old actually, about a hammer factory, and I really like it. I loved reading it. It's about not going factory crazy. You have to keep common sense. The factory design pattern is not always the best solution. So here's the link, read it. I hope you like it as well. So let's dive into the code. So I've made a legacy controller. It's not Cake 2. I've already reworked it into Cake 4, but the gist is in this. So we have a very top-down procedural code. It goes from A to Z, and it will request the school to upload a file that they generated with their software to make schedules. So the first step is to receive the file and then to detect the file's type. We have a detect format function for that. And in that detect format function, we will go about the first line of the file. We have an extension, we have a delimiter, and we have some elements on that line, and we can determine what kind of schedule file it is. So I've made some fake schedule files with I forgot the name, but here they are. They have delimiters, they have a day of the week, and they have a certain amount of time. And each file will have their own kind of properties, but they should result in a full work week of 5 days. Oh yeah, Cupcake Ipsum was called. So I have all these suites for the database. So yeah, we've got 3 different flavors, and they should all be run into the database and stored there in our own file format. So that's the challenge. So we have to decide whether a file that's uploaded by a school, if it's a super schedule or a calendar expert, or maybe a timetable master. And after all this is done, it will return a result. If it wasn't found, the result will be 0. And a 0 will result in a flash error. The next step is to see if there's a complete week in the file. So we need 5 days. And for that specific check, we have another function that has another switch, which will determine for each line whether there was a date. We collect all the dates in a file, and after that, we will check if the complete week was there. We have 1, 2, 3, 4, 5. If it's also there, then we say, okay, go on. If not, too bad. And then we get to the point where we will move the file to the disk. We'll check if it was already there. We only allow for a schedule to be uploaded once. Once we have it, we don't require it again. So we will say, hey, this was already uploaded. It was the final check for it. Then we will save it into our schedules table with the details. And the final step of the process is to extract all the lines in the given file. We'll first do a small check. Do we already have this file? Then there's another switch, which will go for each and every schedule file. Like, okay, so your table master, what's your start date, what's your end date, what's your day of the week, and what is the appointment that we should save. At the end, this will be saved into the database as a time slot, and we will count all that the records that we stored, and we go to the user and say, well, we did it, re-ran the file, and those time slots were saved. So the pattern that we're seeing here, I hope you see it too, is that we have these switch statements all around, and they're doing basically the same thing each time. There's a file extension, there's a delimiter, there are properties for each and every column within each file that you can determine, okay, this is either a super schedule or a calendar expert file. So that's the pattern that we can use to remodel this into a refactored design. And to do so, we will apply the factory design pattern, which brings me to my next slide. So let's see. So like I mentioned before, you can guarantee the objects that a factory makes with with an interface. These are the steps that are also in the legacy controller. You have a schedule type determination. You have to format a date, and you have to extract a line from each line in a file. You have to know whether a schedule already exists. And the final step was to extract the time slots from the file. So this interface is a kind of a guarantee. It's also called a contract, that each object that will be given by the factory will have these methods. And the factory is made like this. So I've made schedule type for each file, and that is listed in the factory. So the factory has to know which types are available to it. And each type will have properties that are designated for that type. So the calendar expert will have a delimiter, an extension, a label to show, well, this is the calendar expert. It will have its own function for how to determine whether it's a schedule type. So if you upload a file, it will run past this and will say, okay, does it match? No, well, then it isn't a calendar expert. If it does match, well, hooray, you're a calendar expert. Same goes for the format date. It will take the file, look for the right place, and return a date. An extract line will parse an array from the line that has been given. Maybe I'm running a bit ahead, but that's how I designed it, so that no more switch statements. Each schedule type has its own class. So if I have to maintain it, I'll just go to the class and alter it there. If we get a new software, because in reality we have about 6 or 7 schedule softwares that we have to support. If we get an 8th one, I'll just create a new class instead of extending, well, in reality were 5 switch statements. So no switch statements anymore. I just have to add another class, add it to the factory, and it will be completed into the cycle. So to start with the controller, I've made it a lot thinner, so it's been on a diet. I receive a file here, I patch the entity, I save it, and I tell the user, well, hooray, it has been done, or oh no, there has been errors, and I will show a flash message telling, well, there were some issues with the file. So the heavy lifting will be done in the table. So the controller will, it's pretty dumb actually. It doesn't have to know what it's about. And the first step is in the behavior, in the before Marshall. And in the before Marshall, we pick up the request and we'll try to determine which file has been given to us. So by default, the schedule type will be 0. And then we call upon the factory to give us a object. And it will be compliant with the schedule type interface. So we know that we have the methods that are defined there to our disposal. And if it didn't find a schedule file, the schedule type will be 0 and a validation error will be given. So yeah, this was the method that I wanted to explain a bit about, because that's the factory. Factory, yes. So the find by file, just like the faker, gets an argument and it's a file. And based on that file, it will give back a schedule type class with which implements the schedule type interface. So we loop each and every one of these classes, and we call upon the isScheduleType method. And if it's true, then the loop will be broken and will be given back as this is the object you are looking for. If none were given true, then 0 or null will be given back, and the schedule type ID will be 0. And this is the actual function that will create each object. So we make a list and we make a new initialization of each class with the options that were given. In this case, it was the file name, it was the uploaded file. And if we take a look at the schedules table, it will require a schedule type ID. And if it's 0, so no valid file was found, we will report back it's invalid, this file we don't recognize. If it goes on, then we will check if it has a complete week. Just like before, just like the legacy situation, we have a complete week, but we have it in our own class. So you don't really have to go through the switch statements to get there. It would just fire upon, is this true or not? And if it's not, then we'll raise an warning to our user with a flash message saying, hey, sorry, but you're missing a day probably. The same goes for the check if a schedule was already uploaded. We'll call upon the method because we know it's there. It's bound with the schedule type interface. So it will tell us, okay, yeah, this is fine, or it's not. And then we'll raise a message to the user. And if it all goes well, we will go to the after save method. And in the after save, we will try and extract the time slots. And here we have another check to see, okay, we have a schedule, is it still empty of time slots? Run each line through an extract line method, which is located in the proper class. So the calendar expert class has an extract line. The schedule, super schedule class has this function. And they produce an array. We can store the array. We convert the array to a time slot, and we will store it in the database. And at the end of the line, we will just load the time slots into the entity so we know that they're there, and we can tell the user how many time slots have been saved into the database. This is a big file, which I kind of created as a parent file for each class so that I can use functionality for. But it's not necessary for a new class to use this. For example, I have this super schedule type, and it extends the schedule type, but it's not necessary. So if I would have a request for a new schedule software to support, and it's totally different, which probably is, then I can just go ahead and do something completely different for that schedule type, as long as it implements the schedule type interface. Then I can just hook it into the factory and things should work out smoothly. So you can extend your software with classes instead of extending it with more switch statements. That's the gist of it anyway. So the proof of the pudding. So there's no proofing cake, but pudding. Yeah, I made a unit test. I made 2 unit tests to be exact. And they will run a certain amount. They will run a data provider. And I've made exact the same unit test for the legacy controller. We will also use the same data provider. And this will tell me, okay, I have a calendar expert file and it requires 20 results. A super schedule will have 9 results. Timetable master will have 8 results. So that's 8 time slots. The content of these have been the same. I only changed the modules, the tables. So this one uses the legacy schedules table, and the other one uses the schedules table. So that's the only minor difference, and the endpoint is that this one goes to the schedules add, and this one will post to the legacy endpoint. And if we were to run that with a unit test, there we go, then it will check the same data provider against both similar unit tests, which will hopefully have the same output. Well, there you go. That's the proof in the pudding. So there you go. I hope everything was clear.